All right, we are picking our Unit 1 review back up with number 10. So number 10 says, which of the following is true of a function and its inverse? Okay, so real quick, I know that they reflect across the line y equals x. I know that that's true. Some of this other stuff just looks kind of funky. Here it says the domain and range are the same as the domain and range of the inverse. Well, we know the domain and range of the function, they're not the same as the domain and range of the inverse because remember they flippity-flop. So the domain would become the range and the range would become the domain. So I know that's not true. And this one, I don't even know what that's saying. And this says the inverse is always a function, which is not always true. So this is the one we want. So one thing to know about its function and its inverse is they are reflections along this line y equals x. So they reflect over this line right here. Okay. These next two problems say basically the same thing. And it's essentially wanting to know what's going to prove that f of x and g of x are inverses. What's going to prove that f of x and g of x are inverses? So there are several things that have to happen. The graphs have to reflect over this line y equals x. They have to flip-flop their x's and y's. But the really technical thing that has to happen is f of g of x has to equal an x, and g of f of x has to equal an x. And if that doesn't happen, then they are not inverses. So C is the one that we want. So if they ever show you some weird funky notation like this, with this open circle, you read that f of g of x and you read this g of f of x. If you start seeing stuff about f of g of x and g of f of x, they both have to equal an x or they're not inverses. So this is just something that you're probably going to need to memorize. So the only way for things to be inverses are for f of g of x to be x and g of f of x to be x. Okay, so down here, it's wanting to know what would prove these guys to be inverses of each other again. So number one is calculating f of g of x. So do you see how your f of g of x made an x? All right, this one's calculating g of f of x. And do you see how it made an x? So g of f of x also made an x, which both of those have to happen. F of g of x has to equal an x, and g of f of x has to equal an x. If they don't both equal an x, they are not inverses. So both number 1 and number 2 have to happen. If they don't both happen, they're not inverses. So these two problems are just trying to get you to memorize that. You need f of g of x to be x and g of f of x to be x. And if they don't both do that, they're not inverses. Okay, just try to store that away in your memory bank. All right, next one. It asks for the domain. All right, I am going to blow this up so I can see better. You guys are younger than me, so you probably don't need to do that. All right, so domain is asking for x's. So I'm looking left and right. So this is my farthest left point, and this is my farthest right point. There's no arrows, so it doesn't go forever in any of the directions. So my farthest left x point is right there, which is at 1, 2, 3, 4, 5, 6, a -6. That's my farthest left x. And this is my farthest right x, and it is happening at 1, 2. And I've got all the x's in between. Okay, if I just look for something like that down here, where do you see it? A! Bing, 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 bing. The signs will always look like that, and because they're both closed circles, then they both get equal signs. Okay. Let me unzoom that a little bit. All right. So, number 14 is a word problem situation, and we did not teach those this year. We did not do domain and range of word problems, so I am going to get rid of it. All right, number 15. It says, which of the following represents the range of f of x equals 2 to the x plus 3? All right, so I'm looking for y's. So first, I want to look at this graph and see what it looks like, and then I'm going to figure out its range. Okay, so here comes my handy dandy graphing calculator. Oh, how fancy. 2 to the x was the last one I put in there, so I don't even have to retype all that. So I'm just going to right arrow, and put plus 3. Okay, so now I'm going to hit graph, and we want to know something about its range. Okay, so this guy right here, so I'm just going to hit trace for a second. This guy right here is the point 0, 4. All right, so my y value is a 4 right there. I'm going to left arrow and see what happens. Now, look at your y's because we're doing something with range, right? So look at your y's. The y's are getting closer and closer and closer to being a 3. This is an exponential function, and exponential functions, remember, have asymptotes that are horizontal. So this graph is going to have a y value that's getting close and close and close to being a 3, but it's never going to equal the 3 because there's an asymptote on your exponential function. Okay, so when I go to do range, my y is getting close to being a 3, but it's not going to equal it. And then when you go to the right, I'm sorry, y's are up and down. As you start moving up, your y's get greater. So that is our range. Now, if I did interval notation, it's starting at 3, and it goes forever up, so it's headed to positive infinity. And then because of the asymptote, it can't equal the 3, so the 3 is a parenthesis, and then infinity is always a parenthesis. All right, so let's see. Which of the following represents the range? Okay, so number 1 says exactly what I have over here, so that's good. Now number 2, it says this all over again, but with the y such that. So this is your set builder notation, but this says the exact same that does. So that's good. And then these both are showing the 3 to infinity, but the problem is we can't have the bracket because it doesn't equal the 3. That asymptote prevents it from touching or crossing. So this one is good, but this one's out. So when it says which of the following represents the range, it's 1, 2, and 4. So that is answer choice D. Okay, moving on. Number 16, we've got another word problem going on here about domain and range, and we skipped that this year for time purposes, so I'm going to skip it too. All right, now number 17. It wants to know which of these are not inverses. So there's lots of things I could do. I think the easiest thing to do would be to I could look at the table of this and then look at the table of this and see if they flip-flopped x's and y's. That'd be the least mathematical way of doing it. I could solve this equation by replacing this y with an x and replacing this x with a y and solving. But maybe the table might be the easiest option, but it's going to take a little bit. Okay, so answer choice A. So I'm going to put the g of x equals 2x plus 9 in the graphing calculator and take a look at its table. Okay, so I'm going to look at the g of x table first. And then I'm going to put the h of x in the calculator, and I'm going to look at its table. And if they're flip-flops of each other, then they are inverses. If they're not flip-flops of each other, then they're not inverses. and then I'm going to have to do this for B, C, and D until I find the correct answer. So a little bit of a pain, I'm not going to lie. Okay, so, but I think it's going to be the easiest way for you guys to do it. So I'm going to type in 2x plus 9, and I'm going to look at its table. So I'm just going to go second graph. All right, so I see here -4, 1. I see, I'm just going to write some of them down. -2, 5. Let's do a positive one. 1, 11. Okay, so now I'm going to put the h of x in and see if these points are flip-flopped in that one. Okay, so they should look like this. So let me go ahead and flip-flop them. 1, -4. Flip-flop it. 5, -2. Flip-flop it. 11, 1. And I'm just doing some mixtures of positive and negatives. Okay, so when I put h of x in, if I don't see these numbers in the table, then that means they're not inverses. Okay, so let me type in h. All right, so I'm going to go to my y equals. And there's different ways that you can do 1/2. I'm going to go alpha y equals. I'm going to hit enter. I'm going to put 1 on top, arrow down, put 2 on bottom, right arrow over, hit X, and then -9. Okay, so now I'm going to look at the table, and I'm going to see if it matches what I'm saying it should look like. So let's go to the table, and I want to look for 1, -4. Let's see. Do we see 1, -4? We do not. And 5, -2? We do not see 5, -2. So right off the bat, these guys are not inverses. And that's because your x and y values did not flip-flop to make the x and y values for this guy. So I'm lucky. I don't even have to do B, C, or D. But that's how I would do B, C, or D if I had to. Okay, so study for your test. Watch this review as many times as you need to. And good luck. Smiley face.